Okay, today we will look at the exercise of simple fixed point iteration. So before that, I revise a little bit on this. Okay, before we move on. Okay, this simple fixed point iteration, given a function, okay, given a function where the function must be equal to 0, because you are given an equation actually. So from that equation, we have to find the root. Okay, we have to find the root, and you will be given a starting point. We have to use a starting point instead of starting interval, and you will be given an epsilon. Okay. So to use this method, we have to find for the gx. Okay, find for the gx. So you can find a field, okay, gx. Okay, because there are infinite gx for you to use. Okay, normally we just form the simple one. Okay, so these are the 3 examples of different gx. So the gx, before you use, you have to test for the criteria. Okay, that's when you have to find for the derivative, you differentiate the function, and then you substitute the x by starting point. Then take the magnitude value. The magnitude should be less than 1. Should be less than 1. Okay, so if it is less than 1, this means you can use that gx to get a solution. Okay, otherwise, okay, we can't use that gx. If the criteria is not being satisfied, we can't use that gx. Okay, so now we look at this exercise, exercise 2.3. Okay, locate the root of this by using simple fixed point iteration accurate to within this 0.003. Okay, and you are given an interval. That means you can choose your starting point from this interval. So which value will you choose? Can you choose 0? You can't choose 0. If you want to choose, you can have 0.1, 0.01, but not 0 because of this bracket. This does not contain 0. Okay, or you can choose 1. Okay, this means 1 is included. So you can choose 0.5 or 1. Okay, doesn't matter as long as it lies within this interval. Okay, because of this, x is the subset of this one. Okay, because of this symbol, okay, your x must satisfy this. Okay, but not 0 is not included. Okay, 1 is included. Okay, then you have to present your answer in 4 decimal places. So from here, okay, you can the simplest one, you can use this x, right? Okay, your x can be e negative x. Okay, your x can be e negative x. Okay, your x is e negative x minus x. Okay. So we know that fx equals to 0. So we want x. Okay, that's mean your x is e negative x, right? So this is your gx. Okay, this is your gx. Okay, this gx. Okay, this is your gx. Gx is e negative x. So what is your g prime x? Then you need to test for this. Your starting point, let's say you take 1. Let's say you take 1 as your starting point. Okay, then we have to look at this magnitude, whether it is less than 1. Okay, so when you differentiate this, what do you get? What do you get? Differentiate exponential function. Negative e negative x. Okay, now substitute 1 into this. Okay, that's when we want to compute the magnitude for this. What is the value? Calculator. E to the power of negative 1. And we just take magnitude. So what do you get? 0.3 6 7 9. Right? So this is less than 1. Okay, this is less than 1. This means we can use this. We can use this gx. Can use this gx to get a solution. Can I show you another one? Okay, I show you another one. If you use, let's say the x from here. Okay, then e negative x is x, and we want this one. So negative x is 1x, right? X is negative 1x. Okay, so this is your gx. This is your gx. So we check for the differentiation. When you differentiate ln x, you get 1 over x. 1 over x. Remember how to differentiate log function? This is your fx. You put it at the bottom, and then you differentiate this one, you put it at the top. Okay, this is how we differentiate the log function. Okay, but log x, okay, usually we quite often see this one, right? When we differentiate log x, we get 1 over x. Okay, minus 1. So this one, when we want to check for this means negative 1 over 1, which is 1, right? 1 is not less than 1. So we don't use this. We don't use this. And now use this one. Can I run this?
Yes.
Okay, Gx is E negative x. X is E negative x. Okay. And you can construct the table. You need iteration x and the error. Okay, iteration start from 0. The starting point 1. I took 1 just now. Okay, no error in first row. You know, substitute 1 into your Gx. Okay, that's been E negative 1.
1.
E negative 1. Okay, so you can key in the formula, okay. Negative x. Negative x. Okay, calculate when x is 1. So you have 0.3679. Okay, and when this one minus 1. Okay, we find for the difference. Okay, the difference, this one minus 1, and we take the magnitude is 0.6321. Right? Okay, this one starting point, we take from the given interval. Okay, and this Gx can be used. Okay, this Gx can be used because just now we have already checked for the condition, it satisfied the condition. So 1 substitute into this x, get this. And then for the error, you find the difference between these two and take the magnitude. Error, it will always be positive. Okay, then next we substitute this into this x. Okay, 0.3679. Okay, so suppose you get a 0.6922, right? Okay, then find for the error. You find the difference between these two and take the magnitude to put it here. Okay, and we will stop the iteration when the error is less than 0.003. Okay, according to the function, 0.003. Okay, weapon sign for your attendance.
Yeah. Ecco, come Em rồi đấy. Chúng nó đã đi không ạ? Ôi, cái chính là đi tận đi tận đi đây và sự kiện cho nó về cái lúc xưa
Okay, so we need 7 iteration. Okay. 0.7 E negative x. E negative x.
是的，对对，你去管理哦。管理，我尽力了啊。管理。有些。
Okay. Any more questions for simple iteration? Error.
That's 0.00. Okay.
This one. This one.
Yeah, okay. I got 0.0001.
2. 2. That's mean.
Here now.
This means you have some rounding difference from this. This means maybe one of the value you take the wrong one. Suppose if you follow strictly and you rounding off properly, suppose you will get the same exactly value. Suppose, okay, but okay, if this is 0. So that means is this your final answer?
Yeah.
Yes. So this is 86. 84. 4. Okay, okay. Just need to be careful and you do the wrong thing. Okay.
Wait.
Now we proceed to the last one. Newton-Raphson. Okay, Newton-Raphson is actually derived from the Taylor series. This is a Taylor series, and then we replace the x by x naught here. Okay. And not replace x. This is something like we are finding the approximations around x naught. Okay. So this is the expansion. Okay, this is the expansion, but we take only up to linear term. Okay. This is linear term because x power of 1. Okay, this one, when you expand, you get x cubed. So this is quadratic term. Okay, so we just take up to linear term. That means we take, okay, for fx, we just take these first two terms. Okay, because we just use, this is kind of approximation. So if we take only up to this, okay, so remember when your x is the root, your fx is 0. All right, when your x is the root, your fx is 0. Okay, so now substitute fx by 0, and then x naught. Okay, x naught here. This is x naught. This is the formula. 1 factorial is 1. Okay, 1 factorial is 1. So that's why you get this formula. Okay, now we rearrange. We rearrange this equation because we want this x. Okay, we want this x. So this one moves to the left. Then this one divided. Okay, this one moves to the left. That means you have this negative f over f prime. Right? Can you see that?
Yeah.
Then we want this x. So this one, you move to the left, it will be a plus x naught. Okay, that means from here, we want this x. We want only this x. So we move this one to the left, you have negative f. And then this one, you move to the left, you have negative f over f prime. Then this one move to the left, you have a plus x naught. Okay. Yeah. Okay. Hence, we will use this, okay, as the Newton-Raphson algorithm, okay, by replacing this knot by xn, okay, n. Okay, the knot, we change it into n, and this is xn plus 1. That means this is the new x, next x. Okay, this is the next x. Okay, this one. Next x, this is the previous x. Okay, we will use this algorithm to construct for the solution. Okay, if you look at this flow, okay, you are given a function, okay, you are given an equation, and then we move the equation, all the terms to one side, then you will get fx equals to 0. Okay, given the starting x naught, the x naught must be reasonably close to the root. That's why if x naught is not given in the question, you have to find from the intermediate value theorem. Okay, you get the range that contains the root, and then you estimate that you just take the x naught from the interval. Okay, we need a starting point that is close to the root. Okay, then you have to differentiate, because according to the formula, you need to have this f over f prime. Okay, so you need to differentiate your fx to get your f prime. Okay, then we will use this formula to compute for the next x. Okay, we will repeat the process until the stopping criteria is being satisfied. So these are the stopping criteria that we can use. So which one to use? Follow the question. Okay, so this one, we find the two consecutive x value. Okay, the difference of the two consecutive x value, it must be less than an epsilon. Or the f value of the latest x, it must be less than epsilon. Okay, so this is the process. Now we look at the first example. Okay, determine the root of this function using Newton-Raphson. Okay, you are given the starting point, okay, and it must be accurate to within 0.0001. So we take this as the stopping criteria. Okay, so this is your fx. Okay, this is your fx. So we need to differentiate the fx. Okay, so differentiate ex, we get ex. Differentiate this one, we get this. So how to get this? Can I show you on the board? Your fx is ex minus 2 over x. Okay, that means we can write this in the form of 2x to the power of -1. Right? So when we differentiate, ex is still ex. How do we differentiate exponential function? Okay, revise a little bit this. Okay, when you have e to the power of a function, okay, when you have e to the power of a function, when we want to differentiate, we will get the same function back, and then we differentiate this one, you get f prime. Okay, this is how we differentiate the exponential function. For example, y equals to e4x. That's mean your dy dx is still e4x, but you differentiate this one, you get a 4. Okay, so when you differentiate ex, you get ex back. When you differentiate x, you get 1. Okay, then -2, -2, and then we differentiate this. Okay, this is a polynomial, right? Okay, x to the power of, not polynomial. This is x to the power of -1. So -1, we bring it to the front, and then x power -1 the -2. Okay, and then times 1. You differentiate this one, you get 1 times 1. Okay, so you have ex plus 2x -2. That's mean ex plus 2 over x squared. The minus means over x squared. Okay, so this is how we get the f prime. Okay, so now once you get your f prime, you can construct for the table. Okay, so this is what you need. Okay, for the table, the iteration, you need the x. Okay, it's fx, f prime x. If we take the ratio, okay, because of this, okay, f over f prime, f over f prime. So this is the stopping criteria given by the question. We want the magnitude of f. Okay. So according to the question, the starting point is 0.8. So this is 0.8. Okay, 0.8. So you substitute 0.8 into fx, you get this. 0.8 substitute into f prime x, you get this. Okay, and then this one is f over f prime. So this one divided by this, you get this one, right? So this is the magnitude of f. Okay, this is our f. So we just take the magnitude of this. Okay, then we want to get the next x. Okay, if we want to get the next x, we use this formula. So this formula means x minus the ratio. So this is your x. This is your ratio. It means 0.8 minus negative 0.0513. Minus minus, you get a plus. That's why you get this 0.8513. Okay? Got it? Use this formula, x minus ratio. Okay? X minus this ratio. Minus minus, you get a plus. Okay. And then you repeat the process. This one you substitute into this 2, you get this 2. And then this one ratio, use this divided by this, you get this. Okay, and the stopping criteria, we take the magnitude of f. Okay, and once again, to get the new x, we use x minus the ratio. Minus minus, you get a plus. So when you sum up these two, get this. Okay, and this one, substitute into this 2, you get this 2. Since this is almost close to 0, okay, when we use 4 decimal places, so you just put 0. So 0 divided by this, 0. Okay, so this f from here, 0. So when this is less than the epsilon, given epsilon, so we stop the iteration, and the last x will be your solution. Okay, Newton-Raphson, it converges very fast. That's why you see, we just need maybe 2 or 3 iterations, then we can get the result. Okay, it converges very fast compared to the simple fixed point and also the bisection. Okay, but to use this one, okay, you have to use the derivative, right? So bisection, we don't need derivative. Okay, simple fixed point in the computation, we don't need derivative. Okay, but this one you need. Okay, you need the derivative, but it converges very fast. Now we look at another example. Okay, this one, starting from 0, accurate within this. Okay, this is the stopping criteria. Okay, this one means we find the difference between 2 consecutive x values. Okay, so this one, when we differentiate this, okay, when we differentiate 3x, we get 3. Sin x, we get cos x. Ex, we get ex. Okay, then the starting point is 0. So we substitute 0 into this f and f prime, we get these 2 values. Yeah, and this one, just use f divided by f prime, you get this. Okay, there's no error for the first one if you use this stopping criteria, because this one we need to find the difference between this one and the previous one. There's no previous one, so there's no error for the first row. Okay, then to get the new x, we use this minus the ratio. Minus minus, you get a plus. That's why you get a positive 0.3333. Okay, repeat the process. Substitute this value into this 2, you get this 2. And then find the ratio. Calculate for the difference between these 2. Take the magnitude. Okay. Then to get the new x, use this x minus the ratio. Then you get this. Okay, you repeat the process until this value is less than 0.5 trigger 0, 1. Okay, this is less than 0.001. So this is your final solution. Okay, actually it's quite simple for Newton-Raphson. Okay, any questions? To get, whenever we want to get a new x, just use the reverse rule, x minus the ratio. Okay, x minus the ratio. If the ratio is negative value, that's means minus minus, you get plus. Okay. Okay, now we try exercise. Okay, differentiate the long function. Remember how to differentiate the long function just now? That function is your fx. You put it at the bottom, and then you differentiate the bottom function. You put it at the top. Okay. Differentiate long function. This is the long function. So this is your function, right? This function you just put it here. Then differentiate this one, you get 1. Differentiate x, you get 1. Differentiate -1, you get 0. That's why you get only 1 here. Okay. Then differentiate cos. We get sign. Plus sign or minus sign? Plus sign. Minus. Okay, and then we have to differentiate this one times outside. Okay, differentiate this one is still 1. It's a 1 times sine x minus 1. So I give you one example. Let's say you have, let's say cos 2x minus 1. Your dy dx, it will be negative sine 2x minus 1. And then you differentiate this one, you get a 2, right?
Yeah. Oh.
Okay, because you have to differentiate the angle and then you multiply it for something. Okay, but since this is 1, the no changes. Okay, starting point 1.3. Okay, 1.3. So now substitute the 1.3 into your f and f prime. Remember, you have the frequency function here, so your calculator should be in radian. Where you will have which one next to before. Basically, we have your quiz one. Very simple question. Just need to find for the inverse matrix. You don't have to find for the inverse matrix. So I plan to have the quiz on Friday afternoon. Is that okay? Do you have time on Friday afternoon? Yeah. Only one question. It's a quiz. You have 3 quizzes. The first quiz is 3 quizzes contributes to 10 marks, right? The first one is 2 marks only. The second and third quiz each carries 4 marks. 4 marks. So 2, 4, 4. This one is my one. Next week. Friday. Is it okay? Yeah, face to face. Face to face. So we go to the bigger room. I'll go to the bigger room for this. And so far, okay, Friday afternoon. Only one question. Only one question. Very simple. You just need to know how to find what the inverse matrix. How to get the determinant. How to get an adjoint matrix. You know matrix, you don't really know how to get the form to the matrix. Adjoint and transfer, then you get the adjoint. Combine with the 1 over determinant, then you get the inverse. Okay, very simple. Okay, but you need to know the flow. Okay, the flow. You have to find this one, then this one, how to get the small factor for each of the entries. Okay, this one. Let me get a balance. Negative. 0.3 plus cos 0.3. Negative 0.2486. Yeah. Then 1 over 0.3 minus sign 0.3 3.0378. Okay. 486.
Kosong poin 5 dapat baik.
You use radian or degree? Which one? F prime. F prime 1/1/0.3 minus 0.3 3.0378.